Okay, so each group put together a presentation on air pollution, and for the most part, they were really well done. But I noticed in talking to you afterwards that people tended to focus only on the air pollutant that they did for their group and not the other ones in the group, which was really not my intention. So I'm going to go ahead and do a screencast on air pollutants that make up AQI and what can be done to reduce it, which is not something that we really focused on the project. So here we go. So AQI, the air quality index, is a scale for measuring the quality of air with low numbers near zero being healthy and high numbers up to 500 or even more being bad, and so or even hazardous. But these are arbitrary numbers that are based on how it affects people's health, not necessarily on concentrations, because it varies from particular, no, from pollutant to pollutant. So these are the five basic pollutants that I expect you to know about, the ones that are affecting our day-to-day life here in the Seoul area and really throughout the world. So one is ground level ozone. The other is carbon monoxide, sulfur dioxide, nitrogen dioxide, and particulate matter. When I say sulfur dioxide and nitrogen dioxide, in truth, there are other oxides of these elements as well. So there's other sulfur oxides and other nitrogen oxides, but we'll just focus on the dioxides being the most common. So let's start with ground level ozone. It's a little bit complicated, so here we go. Basically, remember, ozone occurs naturally in the stratosphere as a result of oxygen molecules interacting with ultraviolet light from the sun and then forming ozone as a consequence. But that's not what happens here at ground level and what we call anthropogenic ozone. So anthropogenic means made by humans. So anthropogenic or tropospheric ozone is basically formed the following way. So ozone is the O3 form of oxygen, and O2 is what we normally breathe. But O3 has that extra oxygen that breaks loose and is very powerful at damaging tissues in our lungs and other organs. So how does it get into the air? Well, so what happens is as ozone forms when nitrogen oxides react with volatile organic compounds, and volatile organic compounds are smelly substances. So when you smell something that smells very chemically, like formaldehyde, gasoline, paint thinner, nail polish, those are all a category of a vast number of compounds called volatile organic compounds. An organic compound is just one that has a chain of carbon atoms with a lot of hydrogens on it, and then other things added. So there's literally millions of these. Um, but in particular, gasoline and chemical solvents, things we use for dissolving or getting paints to dissolve. These are some of the main ones. And so what happens is nitrogen oxides are generally produced from high temperature combustion. And a common place that happens is inside of cars. So the internal combustion engine requires very high temperatures. And at those high temperatures, nitrogen, which is usually a fairly inert gas, reacts with oxygen unintentionally, and it comes out the exhaust pipe of the car. So this nitrogen oxide we see here, NOx, because it's not always nitrogen dioxide, it could be other nitrogen oxides. It reacts with the VOCs, and these VOCs come from lots of different sources, like gasoline that gets out when we're pumping gas or cleaning products, whatever. And so nitrogen that comes from cars and power plants and other things like that burn fossil fuels mixed with these VOCs, and then sunlight shining through it, the sunlight, especially the ultraviolet part of it, uh, triggers this reaction which produces the ozone. So it's a little bit complicated. I understand that. But the thing you got to know is the source materials are nitrogen compounds, nitrogen oxide compounds coming from burning fossil fuels in cars and power plants, which are used to make electricity. And then also volatile organic compounds, smelly compounds, and then sunlight. And I think I just went through all this. Okay, so now ozone, because it requires sunlight to form, it's one of a category of pollutants referred to as photochemical smog. And it's called smog because you often can see it in the air. It makes the air a bit hazy. So when we have air and you can sort of see that the air is cloudy, a lot of times this is ozone that can be part of what's doing that. And because it requires sunlight, we find that ozone levels tend to be higher in the summer months when the sun is higher up and stronger than it is in the winter months when the sun is lower down and shines for less time, even though the underlying chemicals that is produced from nitrogen oxides and VOCs are still present in pretty much the same abundance, if not higher. Now, what does ground level ozone do? Well, it causes irritation of the lungs. So that means that people who have weakened respiratory systems are at risk, or people who have healthy lungs and respiratory systems can end up with weakened ones as a result of exposure to ozone. Also, too, in the environment, it basically it interferes with the stomata, the little openings in the bottom of leaves that allow um, oxygen out, but more importantly, carbon dioxide into leaves, and it interferes with those, so it reduces the productivity of plants, and so that can cause plants to sicken and die and just be less productive. And so that in that way, it affects the entire um, ecosystem. How do we reduce it? Well, probably the best way to do it is by reducing VOCs. That's an easier one to deal with. We can have rules regarding how to do that. It's a little bit harder to reduce the production of the nitrogen oxides, although you could do this with electric cars. It's just that you would then be moving the production of the energy, the burning of fossil fuels, to other places. But basically, if we're going to burn fossil fuels, we're going to make nitrogen oxides. But I'll say, if we produce them in power plants, there are technologies we'll see at the end of this slideshow that would allow us to remove it. So honestly, a great way of moving in this direction to try to reduce ground level ozone in our cities where it usually happens is to get rid of internal combustion cars. So more use of public transportation, but more importantly, moving away from gasoline and LPG cars and moving towards purely electric cars. Carbon monoxide. Well, carbon monoxide is formed anytime there's not enough oxygen to support complete combustion. So basically, if the stoichiometric mix is not ideal for that reaction, you're going to end up often with, instead of CO2 being formed, you're going to get CO. So let's just look down here and say what the ideal one. C8H18 is known as octane. It's sort of the perfect liquid gasoline product. Okay, we'll just use that as an example. And gasoline is really a mixture of many, many, many different compounds similar to this. But let's just say we had this one here, straight chain carbon, eight carbon chain. Now, if we react this with O2, what we should end up getting is CO2 plus H2O, just like when you eat food, which has sugars and starches, and you breathe in oxygen, you breathe out carbon dioxide and water. The same thing should happen in a car engine. But what happens is we often have not enough oxygen, which is, we could say I either have not enough of this or too much of this. If it's not the right mix, one thing that happens is, in addition to get CO2, you get CO formed as well. I don't know if you can see that. You probably can't see this. I'll try to move myself there. You get CO formed as well. All right. And that's the source of the problem. It's just that when we burn fossil fuels, invariably we get the mixture a little bit wrong. We end up producing carbon monoxide. Now, carbon monoxide is basically what it does that's bad is our hemoglobin in our blood, in our red blood cells, is designed to attach to O2 molecules, and then to take those O2 molecules and deliver them to cells throughout our body. But what happens is our hemoglobin will attach to the O in the CO, but then when it gets to a cell, that cell tries to grab the C and it just doesn't work. So that hemoglobin is now basically deactivated. It has this carbon monoxide molecule stuck to it and it cannot get rid of it. And so basically, over time, it builds up in our blood system and it basically reduces the efficiency with which our blood is able to deliver oxygen to other parts of our body. And the most important one is our brain, because our brain uses the most oxygen, is the most easily damaged. So, if you go without oxygen, your brain is the first thing affected. So there's neurologic effects that are basically from our oxygen deprivation. These things include things like dizziness, fatigue, headache, confusion, nausea. Really, the carbon monoxide it's a tough one because there's really not much, again, there's not much we can do about it if we're going to keep using internal combustion engines. So if one thing you could do to limit it would be to move to electric cars. Now, I don't want you to think that electric cars are the answer to everything, but they do reduce a lot of the pollution in cities where a lot of our populations are. And not necessarily from an environmental perspective, but from a human health perspective, this could be a pretty important transition for us to make. Sulfur dioxide and other sulfur oxides is mostly produced because there's sulfur content in coal in particular. And coal, we'll talk about in our a later unit when we talk about energy manufacturing. Most electricity produced in the world is produced by burning coal, and the cheaper coals, like there's different qualities of it. Well, the cheaper coals have a higher sulfur content, and so when you burn it, you invariably release sulfur oxides. Just like you can make carbon dioxide, you make sulfur dioxide, and we put that in the air. The problem with sulfur dioxide is, well, basically, I just want to get ahead of my slide. It's basically the main sources are oil refineries. The main ones being power production facilities where we make electricity, but there's also oil refineries, paper production. I mean, I've lived near paper factories. You can smell the sulfur in the air, and cement manufacturing, among others. Now, a couple problems with it. Okay, one is SO2 when it reacts with water, it forms sulfuric acid. Now that's not a great thing. It doesn't make it in very high concentrations. It doesn't like dissolve you or anything like that. But uh, it does produce basically acid in our lungs, which is not good for us. So it causes irritation of the lungs and throat. Uh, but when it in larger amounts, it accumulates in nature in what we call acid precipitation, mainly acid rain. So it lowers the pH of soil, and in doing so, it makes it harder for plants to absorb nutrients. And so we find is we can get pretty significant environmental destruction as a consequence of this acid precipitation. We'll talk about it in more detail later in the unit. But that's the main thing that sulfur dioxides do is they're one of the main constituents of a situation known as acid rain or acid precipitation because it can also be snow and fog. Nitrogen dioxide or other nitrogen oxides, it's very, very similar to sulfur dioxide, except in this case, it's not low quality coal that's the problem. It's just internal combustion. So it happens in cars, it happens in power plants. Basically, nitrogen, as I said earlier, it reacts at high temperatures with oxygen, forming nitrogen oxide compounds. And so it's sort of an unintended consequence of burning fossil fuels. Again, if we move to electric cars in the city and burnt the made the electricity by burning coal outside of town, would help from a human health perspective. And one thing I should note about it is when the air has that brownish color sometimes that you see, that's the nitrogen oxides. I don't know if you saw this in chemistry class, but when you work like nitric acid or something like that, these nitrogen oxides definitely make this weird brown color in the air. So when the air turns brown, it usually means not nitrogen oxide. Well, what does it do? Well, it's very similar to SO2. So instead of making sulfuric acid, it makes nitric acid. Again, not a great thing. So it's another component of acid rain, acid precipitation. Very similar effects. When it breathes into your lungs, it turns into nitric acid. And same things. It basically makes it very difficult for plants to absorb nutrients, and it damages human respiratory and pulmonary systems. And the last one we had to talk about is particulate matter, PM. And we usually divide it up between PM10, it means 10 microns, or 2.5 microns, which is just the size of it. Okay. And these can be, and I know this one's a little bit confusing, and don't worry, I'm not going to test you really hard on it, but we should know a little bit about it. This is an environmental science class. We should try to wrap our heads around this a little bit, but you should know this is a complicated one. This is a hard one to fix. So what we're talking about here are solid particles or liquid droplets that are very, very small, and therefore they can be easily inhaled into our deep into our lungs and even get into our bloodstreams. So the larger particulates, they tend to make the air look a little bit hazy. The smaller ones, the air can look absolutely fine, but have a lot of PM 2.5. And, that means 2.5 or below, and it can still be affecting your health and affecting the environment. You just don't notice. So now this one can come from natural sources, unlike the other ones. There are natural sources of this as well. Two main ones being sea spray. If you ever lived near the ocean, it's often kind of hazy, and it can be a little bit corrosive, and it's not damaging to people, but it definitely affects the environment. There's a lot of plants that can't live near the ocean because of the amount of this pollutant, I guess, which is this natural pollutant. Another one is smoke from wildfires. So when wood is burned, some of the soot that's produced is this little fine dust particles that stay in the air for a long period of time. But of course, in this class, we're mostly concerned about anthropogenic sources, man-made sources. So some of these include dust. Just like if we build roads or we uh, build things, there tends to be a lot of dust generated when we destroy things. So when we break buildings down, we make a lot of dust. Well, some of those dust particles are very small, and so they'll stay in the air as these PM, this particulate matter that's very small, and can travel a long way. Another thing that produces it is combustion of wood and fossil fuels. So burning gasoline, burning coal produces these. sometimes as solid particulates, sometimes as liquid droplets in terms of sulfur dioxide or nitrogen dioxide. They're both their own pollutant, but they're also particulate matter in terms of little liquid droplets that are super small. But then the main sources that we're probably concerned with is power generation, domestic heating, and transportation. These are the main things that we have some control over that are putting this in the atmosphere. And as I said, this is a particularly unhealthy one. It can get very deep into our lungs and cause pretty significant weakening of the respiratory system and inflammation. And it, quite frankly, kills quite a few people every year. And it accumulates, unfortunately. Once it gets in your lungs, you can't get it out. So, at your age, your exposure is much worse than my exposure because, I'm not going to be able to accumulate as much of it. But if we leave this unchecked, then what happens is as you go through your lives, you will accumulate quite a bit of this. So it is a matter of concern. It needs to be dealt with, and it can be dealt with. So let's look at how we can deal with it. Because as one thing I asked you to do is if you look at other countries, you'll see that that in Europe and North America, the air is much, much cleaner. And that's no accident. They put in place laws that basically forced industry to do their thing in a more expensive way, and they just pass that cost on to the consumer. But people don't notice it after a while. I mean, at first people argue and complain about it, but once you do it, it works. And I'll tell you, when you live in a country with healthy air, if you've ever been to Europe or the United States where the air is much cleaner, it's really nice. And when you come to Asia, it's kind of depressing when the air gets really gross, and it doesn't need to be that way. Believe me, the technology exists to have better air than what we have. Okay, now, and I will just say this, okay? It is not a good idea to simply blame China. I know I hear that by so many people here, but I'll just say, sure, there's plenty of pollutant that comes here from China, especially PM. Okay, but there's things we can do, and if we can help, we should. We shouldn't just say, "Oh, what can you do?" And you can do a lot. Okay, let's look at some things that can be done. Okay, it's called scrubber technology. Now, this is something that can be done at industrial sites. So when we have if we're burning things, whether it's making burning coal to make electricity, whether it's smelting metals or making cement, all these things require high temperature burning, right? And they have these smokestacks. Well, a lot of the pollution we're dealing with is coming out of these smokestacks. Well, guess what? You can take that. Here, let me just move myself here. You can take that incoming smoke that would instead of just putting up the chimney, you can put in this expensive technology, and look what happens. The polluted air has nitrogen oxides, sulfur dioxides, mercury. It's just got all this terrible stuff. It comes in here and it has to pass through this mist. And this mist is not just water. It's water that has certain compounds in it, carbonates and other things that will react with a lot of these bad particles and neutralize them, so that by the time this smoke passes through this, uh, most of the particulate matter in it, most of the contaminants, the sulfur dioxides, the nitrogen oxides, the particulates, they all get washed down to the bottom, and what comes out is very, very clean air. This is why they have clean air in Europe and North America, because they require this technology to be put in place. It's expensive, it's difficult to manage, but it does work. Now, this is called a wet scrubber system. Now, there's also dry scrubber systems. Oops, that's not what I wanted to do. Let's try this. Okay, a dry scrubber system. So in this case, what happens is the polluted air from the smokestack comes into here, and now it's just going to pass through. We'll just call it a filter system, and this filter has chemicals embedded in it that are able to react with to neutralize these pollutants or to absorb them. One of the main things we use in here is called activated charcoal. And basically, as this just passes through here without getting wet, as it comes up to the top and exits, uh, the pollutants have gotten stuck in here. Well, it should be pretty clear what's going to happen here is this has to be swapped out, and then a new one put in, and the one you took out has to be cleaned and repurposed and put back in. So it's very expensive. It requires having extra smokestacks so you can shut one down while you treat the other one, but you end up with air that's breathable and that isn't unhealthy. And so this is definitely a technology that's worth investing in. And the more you invest in it, the better it gets. And then finally, there's another one called an electrostatic scrubber. This is what we have in the classroom right here. It's what you have in your house, chances are. If you have an air purifier, here's what it does. You take now, the air purifier in your house brings air in and passes it through the system. But if it's just a smokestack, we have this waste gas containing these smoke particles and things we don't want to escape. And what we do is we have high voltage electricity. So basically, we have a mesh that has a negative electrical charge. So as these particles pass through it, they pick up a negative charge. Well, up here we have a positive electrical charge plates, right? So we just separate this charge. So these particles pick up a negative charge and they stick to this plate. And then they've set up ways to shake it and do things to collect the stuff, right? Um, and then what comes out really has very little of the particulate left in it. It's expensive. It requires power. Sometimes you have to shut the system down to remove these and clean them and put them back in, when these things don't work. But again, these are three technologies that have been proven to work. They're used in industry right now, and they're ones that are definitely worth investing in and requiring industries to use. Okay, so that was air pollution. Thanks for watching. Sorry this took so long.